Welcome back to the last topic of the day, which is converting between natural logarithmic and exponential equations. So before we get into natural log, let's talk about e. So e, as you can see, is approximately 2.718281828 dot dot dot. I know it might seem like a pattern by the 1828, but if I had kept writing the decimals, you would see that there is no pattern. Since there is no pattern and it goes on forever, it is irrational, just like pi. So e and pi, they're called universal constants, right? So the natural logarithmic function, it is y equals natural log of x. So when you see, y equals natural log of x. So natural log of x, that is the same as saying log base e of x. Okay, so as you can see in the bottom, I showed you an equivalent form, but let me show you. So if I have y equals log base e of x, and we know that y equals log base b of x is equivalent to b to the y equals x. Okay, so over here, put in a different color, y is still y, our b is e, and x is just x. Okay, so what is this equivalent to? This is equivalent to e to the y equals x. Okay, and as you can see, this is what we get there. So so what do we know about the log base e of x? This is also natural log of x. So that's how we get y equals natural log of x, which is equivalent to e to the y equals x. Okay. So if f of x equals natural log of x and g of x is equal to e to the x, so those two, natural log of x and e to the x, they are inverse functions. So in other words, when we take the composition of them, we will get x. So natural log of e to the x is equal to x, and e to the natural log of x is equal to x. So tomorrow we're going to be talking about properties of logarithms, and so maybe, hopefully, it'll be more clear why e to the natural log, they cancel, okay, and that's why we got the x, okay, but for right now, you just gotta believe me. So now, let's go ahead and do some examples. Right? So our directions are to rewrite in equivalent form. Right? So our first example, we have natural log of 9 is equal to x. Right? So what is it? So if we, I guess we can talk about this a couple of ways. So first, let's rewrite this. This is the same as log base e of 9, which equals x. So essentially, you don't really have to memorize this one. As the main thing you just have to know is you have to know y equals log base b of x is equal to b to the y, is equivalent to b to the y equals x. Okay, as long as you know this, and as long as you know that the natural log of x is equal to the natural log base e of x, okay, you're golden. So if we do this, okay, and then we establish, so in our case, y is equal to x, b is equal to e, and then x in this case is equal to 9. Okay, I know it gets a little confusing because there's multiple x's, but these x's aren't the same, right? And that might be one reason why Alex uses A, B, C instead, right? But I'm sticking with X, Y, and B. So what is this? So this is equivalent to e to the x is equal to 9. Okay, and that is its equivalent form. Okay, you could have also just told me, so natural log of 9 equals x. So one thing, so if you notice here, okay, if you take so e to the natural log, or natural log of e. So essentially, they reduce to 1. Okay, so e and natural log, they are 1, so it's just whatever's left over. So one thing that you could have done is we could have taken e to the natural log of 9 and then e to the x. We know e to the natural log, this is 1, so this becomes 9 equals e to the x. Right? Either way will work. So now let's do one more example before we call it a day. Okay, and the final example we're going to do is e to the y is equal to 7. Right? So again, let me bring down this. Right? So in this case, we are in exponential form. So what do we need to do? We need to be in logarithmic form. So in order to do that, we have to rewrite it. So in this case, b is e, y is y, and then our x is 7. So this is equivalent to y is equal to log base e of 7. But what do we know about log base e? Log base e is natural log. Okay, so it's y is equal to natural log of 7. The final way, so another way you can do this, okay, is if we have e to the y is equal to 7. So we know like so e to the natural log of x, this is x. But we also know natural log of e to the x is equal to x. Okay, so we used, which one? We used this one for this example. I'm going to use this one for this example. So let's take the natural log to both sides. All right, so as you notice, oh, I didn't use it for this example. Sorry, I used this one for example 1. Okay, so if you notice in example 1, I still took the e to both sides, right? Because I still have to, even if no matter what, dealing with like the exponentials, logarithms, x's, numbers, it doesn't matter. We still have to balance our equation. So if we took e to both sides, it'll still be the same. Same case here. If I'm going to take the natural log of one side, I have to do it to the other. Okay, got to keep this balanced. Okay, but what do you know about natural log of e? That is 1. So this becomes y, and then natural log of 7. All right, either way works. All right, just do the one that you are most comfortable with. So this is logarithms, just an introduction to them, and we'll talk about its properties tomorrow. So don't forget about your homework. That is due on Friday. So, and if you have any questions, just let me know. But if not, I will talk to you guys tomorrow. Bye.